in section 1.2, we solve the easiest kind of differential equations to solve. The easiest kind of differential equations to solve are differential equations in which the dependent variable does not show up. All right, so that's some fancy words. What does it mean to say the dependent variable does not show up? Which variable is the dependent variable? Y is the dependent variable. So my differential equation is not going to have y's over here. It's just going to have x's. So for example, I might have dy dx equals, somebody give me a nice function that only has x in it. X plus 1. I like it when you make it easy on me. And let's have an initial condition. Y at 0 is 2, 1. I'll go with 2. I heard the 2 first. All right, so there's a differential equation. It's a differential equation where the dependent variable is not in the equation. There's no y there. How do you solve that differential equation? So you're gonna move the dx over. All right, you don't really need to do that, but it's not a bad thing. And then what are you going to do? You're going to integrate both sides, aren't you? I wouldn't have moved the dx over. I would have just integrated right from the beginning. Integrals do what to derivatives? Cancel them out. They're inverses. So y is the integral of x plus 1 dx. And that's why this section is called integrals as solutions. We simply integrate, and that gives us the answer. So that's going to be 1/2 x squared plus x plus c. And then we have to find the c value. How do I find the c value? Plug in my initial condition. So 2 equals 0 plus 0 plus c. I guess c is 2. Solution is y equals 1/2 x squared plus x plus 2. Questions on that one? All right, let's try another one. That was so much fun. That was so easy. I like easy ones. dy dx equals x e to the negative x. And then how about y at 0 is 4? How do you solve? Integrate both sides. So y is the integral of x e to the negative x dx. What's the integral of x e to the negative x dx? Ah, very good. This is an integration by parts problem. Absolutely. I could, if I like the tabular method for integration by parts, absolutely, I could use the tabular method. People remember the tabular method for integration by parts? Do you like the tabular method better? No, you don't remember it? I got to talk to your Calc 2 teacher. I was his Calc 2 teacher. So. I'll have a long conversation with myself tonight. All right, so I'm going to do it by the tabular method. And the reason I'm going to do it by the tabular method is we will have later on in this course a lot of integration by parts problems. And the tabular method is a lot quicker. Okay? So the way that tabular method worked is you build a little table, your u and your dv. You needed to pick something to be u. What should we pick to be u in this case? X. Why do you pick x? Because when you take its derivative enough times, it'll go to 0. In fact, you take the derivative once, you get 1. You take the derivative again, you get 0. And then dv had to be everything left, e to the negative x, dx. And you integrate that. What do you get when you integrate e to the negative x? Negative e to the negative x, that little minus sign in the exponent. That's really a u substitution problem. Negative e to the negative x. And I integrate it again. E to the negative x. All right, so how did that tabular method work again? You Draw little wavy lines. Yeah, all right. So your first term, you start here, and you go to there, and that one gets a positive. And then you go to the next row, you go this one, and you go one down, except that one gets a negative. And then we're done, because when we hit here, we get 0. But if we didn't have 0 there, we would keep going, and the signs would alternate positive, negative, and there's our answer. So the answer is y equals, I'm going to have x times negative e to the negative x minus 1 times e to the negative x plus c. So I'm just going to simplify that a little bit. That's negative x e to the negative x minus e to the negative x plus c. If you don't remember that tabular method, that's okay. You might want to go back and review it, because like I say, we will do a lot of integration by parts later. It'll make your life a lot quicker. It'll make your homework problems go by a lot quicker. All right, so still not quite done yet. Last thing to do, solve for c. So I plug in my initial condition. 4 equals 0 minus 1 plus c. So c is 5. Final solution, y equals negative x, e to the negative x, minus e to the negative x, plus 5. Questions on that one? All right, let's try one more. How about, steal one out of the book here. dy dx equals 1 over the square root of 1 minus x squared, and our initial condition, y at 0 is 0. All right, so again, it's an innocent looking little problem. Y is the integral of 1 over the square root of 1 minus x squared dx. Looks simple enough to start, but then it gets hard in a hurry. Why does that get hard in a hurry? U substitution, unfortunately, does not work. This is a trig sub problem. How come U sub does not work? What would you let U be? You would let U be 1 minus x squared, and your du would be minus 2x dx. There's no x in here in the integrand for that U sub to work. So unfortunately, that's no good. U sub does not work. So you have two choices at this point. Choice number 1 is, there's a formula for this that perhaps you've memorized. Choice number 2 is, this is a trig sub problem. So I picked this one on purpose because it was trig sub. So let's practice our trig sub again, just for good times. What about that problem tells me that it is really trig sub? I mean, how do you recognize it's trig sub? Nothing else worked. Okay.
They're smiling like, what are we going to use?
So they're smiling like I picked a really hard one. Okay.
1 minus x squared. Yeah, 1 minus x squared.
Trig sub usually happens when you have a combination of square roots and you have squares underneath. That's usually your big indication of that's a trig sub problem. You try U sub first because U sub's a lot easier. If it doesn't work, that's almost always a trig sub. All right, so in this case, I think we want to let x equal sine theta, because 1 minus x squared would then be 1 minus sine squared theta, and 1 minus sine squared is cosine squared theta. So that's going to let us get rid of that square root right there. And then dx, the derivative of sine is cosine theta d theta. All right, so our integral becomes, we have 1 divided by cosine theta, because 1 minus x squared is cosine squared. The square and the square root reduce each other. And then our dx is cosine theta d theta. Well, as far as trig sub goes, that's a nice easy one.
Nice.
So the antiderivative of 1 is not x,
Theta.
it's theta, because our variable here is d theta. So this is theta plus c. But our problem started with x's. This should probably end with x's. So I come back here, I get the theta all by itself. Theta is sine inverse of x. So this is sine inverse of x plus c. There's our solution. So you see, trig sub isn't always hard. That was an easy one. Most of them are a lot harder than that. All right, initial condition. 0 equals sine inverse of 0 plus c. What's the sine inverse of 0? It is not 1. 0? You don't say that with confidence. Sine of what angle gives you an answer of 0? The sine of 0 is 0. So the sine inverse of 0 is also 0. So 0 equals 0 plus c, which tells me c is the number 0. The solution to that differential equation is y equals sine inverse of x. Okay, what if I had a similar problem, except instead of having first derivative here, what if I had second derivative? What would you have to do? You'd have to integrate twice, wouldn't you? And what happens when you integrate twice? You get two constants. So how many initial conditions would I have to give you? I'd have to give you 2 initial conditions. Okay? So let's do one of those real quickly. We'll make it an easy one, though. How about y prime equals, give me something that's going to be easy, 3x squared. And then the initial conditions, you're usually going to have something like y at 0 equals 5, and y prime at 0 equals negative 2. So that's the way your initial conditions will usually be given. One will tell you something about the original function, and one will tell you something about the derivative. All right, so, that's not supposed to be y prime there. That's supposed to be y double prime. That was the whole point of this problem, y double prime. All right, so we integrate once. When we integrate once, we get y prime is the integral of 3x squared dx, which is x cubed plus c. And then I plug in this initial condition right away to find the value of c. And then I'll integrate again, and I'll plug initial conditions in again. So when I plug this in, I get negative 2 equals c. So y prime is x cubed minus 2. Y is then the integral of x cubed minus 2 dx, which is 1/4 x to the 4th minus 2x plus k. And I'm going to use the letter k because I already used the letter c. We don't usually use the letter c twice. We use different letters. And again, I plug in my initial conditions. I have 5 equals 0 minus 0 plus k. So k is 5. Final solution, y equals 1/4 x to the 4th minus 2x plus 5.
Isn't it x cubed plus 2? Oh,
Nope, turned out to be a negative 2.
all right.
Because my initial condition had a negative 2. Questions on that? All right, now, you actually did something like this way back in Calc 1. You've probably forgotten about by now. Yeah, you forgot all your Calc 1 stuff? All right, so back in Calc 1, we actually solved a differential equation. We just didn't call it that. And we said something like, assume you have constant acceleration. What's acceleration?
Second
It's the second derivative of what? Of position. So what I'm telling you here, usually position is given by the function s of t. So what I'm telling you here is the second derivative of s is constant. Usually that constant is a for acceleration. So if I know that the second derivative of position is constant a, how do I find my position function? I integrate once. If I integrate once, that gives me s prime, which is another name for velocity. This is our velocity function. This is going to be at plus some constant, but what does that constant have to be?
0.
Not 0, always. Sometimes 0, but not always.
Initial position.
Not initial position, but you're close. It's initial velocity. The constant that you would have here would be initial velocity. Because just think about it for a minute. If you plug 0 in for time, you're going to have 0 plus some constant equals the velocity at 0. So there's your initial velocity. You integrate again, you get position is 1/2 at squared plus v naught t plus some other constant. This is your initial position for the same reason. If I plug 0 in for t, I get 0 plus my constant. And over here I would have s at 0, which is my initial position. All right, so let's take a look at this one. It says, a projectile is fired straight upward with an initial velocity of 100 meters per second from the top of a building 20 meters high and falls to the ground at the base of the building. Determine its maximum height above the ground, when it passes the top of the building, the total time in the air, and velocity when it hits the ground. It's just like you're back in physics. That's right. All right, so my first question is, can we write a position for its formula? Formula for its position, I mean? Okay, so what is it? What's the acceleration due to gravity on Earth? Negative 9.81 meters per second. Unfortunately, well, it did say meters in this problem. All right. So that's going to be minus 4.9 t squared then, isn't it? Because that had a 1/2 a. So that's minus 4.9 t squared plus initial velocity, 100 t, plus initial height, 20. All right, so there's our position formula. Okay, so now that I know I have its position formula, how am I going to find its maximum height?
Solve for t.
Solve what for t? Take the derivative? Why do you need to take the derivative? Because we take the derivative, we set it equal to 0. Where the derivative is 0 gives you your maximums and minimums. This is all back in Calc 1 stuff, isn't it? Or you graph it. Or a third option is, what kind of graph is that? It's a parabola, and there's a little formula for how to find the maximum of a parabola, isn't there? Negative b over 2a? No? No. All right, we'll do it the Calc 1 way then. So what we would do in Calc 1 is we would take the derivative. We would get negative 9.8 t plus 100, and we would set that equal to 0. And we would get t is 100 over 9.8. Which I'm going to leave as 500 over 49. And then we would take that t, so that gives us the time when it reaches the maximum. But then I want the maximum height. How do I actually find the maximum height?
Substitute back in position.
Substitute it back in a position function. And how do I know this one's the maximum?
Equal to 0.
True, but how do you know it's not a minimum? It's just it's a critical number. Critical numbers can be minimums or maximums or neither. How do I know this one's the maximum that I'm looking for?
It's by logic.
My answer would be, well, you could either say this is a parabola opening downward, so this has to be the maximum, or you could use the first derivative test, draw your number line, and show me that it really is a maximum. All right, so S at 500 over 49 is negative 4.9 times 500 over 49 squared plus 100 times 500 over 49 plus 20. I get 530.204 approximately. So it goes approximately 530 feet in the air, or 530 meters in the air. So there's the answer to part A. Part B, when does it pass the top of the building?
On the way down?
On the way down, that's correct. Can you be more specific? I want to know the exact time when it passes the top of the building. How high up in the air will it be when it passes the top of the building? It'll be back up to that 20 meters, won't it be? So we want negative 4.9 t squared plus 100 t plus 20 equal to 20. When does it pass the top of the building? When it's 20 meters in the air again. Subtract 20, those reduce out. So you have minus 4.9 t squared plus 100 t equals 0. What's your favorite way for solving that equation? Take out a t. So t times minus 4.9 t plus 100 equals 0. T equals 0, which we knew because it started at 20, or t equals 100 over 4.9. Approximately 20.4 seconds, exactly 1,000 over 49 seconds. Part C, total time in the air. What's that? The position would equal 0 because when it's not in the air anymore, it's hit the ground and its height is 0. So we want to solve minus 4.9 t squared plus 100 t plus 20 equals 0. What's your favorite way to solve that equation? Quadratic formula? Okay. Program quadratic formula. Minus 4.9, 120. So it hits the ground at approximately 20.6 seconds or negative 0.198 seconds. One of those answers is not good. Which one do you like? Negative 1 is not good. So t equals approximately 20.6 seconds. Happens to be exactly negative 10 plus the square root of 1,039 over negative 9.8. If you want the exact answer. And then finally part D, what's the velocity when it hits the ground? Well, I take my velocity and I plug in my 20.6 and I see what I get. So negative 9.8 times 20.6 plus 100. Negative 101.88 meters per second. Questions on that one? All right, then, let's take a look at number 2. A car is traveling 60 miles per hour, which of course is about 88 feet per second. And it slams on its brake and it skids for 176 feet after its brakes are suddenly applied. Under the assumption that the braking system provides constant deceleration, what is that deceleration? And for how long did the skid continue? All right, so what do we know? You know what? We know the initial velocity. We know V0 is 88 feet per second. Okay. What else do we know? Final position. So we know S, I'm going to call it T final. Final position is 176 feet. Anything else? Constant acceleration. So acceleration is some constant K. In fact, I don't like writing it that way. I think I'm going to write S double prime as acceleration. I think I like that better. Anything else we know? I think there's one more thing we know. What's that? No, it slid 176 feet. When it gets to 176 feet, that's when it stops.
Then it says for how long did the skid continue?
For how long, it means time. It wants to know what was the time of the final velocity is 0, isn't it? So when our position is 176 feet, that's when the car is stopped. So we know our velocity at the final is 0 feet per second. All right, so what do we do? Okay, so let's write down our formulas. If we know that if we don't really need to integrate them, we can just use the facts that we know. We know that position acceleration is the second derivative. We know that velocity is AT plus V0. And we know position is 1/2 AT squared plus V naught T plus S0. Don't need to actually do the integrations. You're allowed to just state those as facts.
The second equation to find acceleration.
Use this one
Yeah.
to find the acceleration. Okay, how's that going to work?
No, I don't know time.
Don't know the time, do we? So start at the beginning.
You know V naught.
I know V naught is 88. All right, so that might help. V of t is AT plus 88. And S at t, I suppose, is 1/2 AT squared plus 88t. What's our initial position? 0. We're going to call our initial position 0, and then we skidded for 176 feet. So initial position is 0. Oh, we didn't write that down. There we go. That's helpful. Okay, we're getting close. Somebody was close when they said, plug this information in. When I plug this information in, I'm still going to have two variables here, aren't I? But I think that's okay. I'm going to plug that information in. I'm going to get 0 equals A times T final plus 88. But I'm also going to plug in the T final information into my position formula. So I have 176 equals 1/2 A times T final squared plus 88 T final. Notice what I have now. I have two equations, but how many variables do I have in each equation? 2, and they happen to be the same two variables, don't they? So we end up with a 2 by 2 system of equations, two equations, two variables. How do you solve that system, two equations, two variables? I don't think you can use a matrix method. Because, unfortunately, this one over here on the left is not linear because the two variables are being multiplied together. And this one here is not linear because it's got a variable squared.
One in terms of the other.
And you're going to have to get one in terms of the other. So I think I'll take this one and write t sub final is negative 88 over a. Subtract the 88 and then divide by the a. So I can take that, plug it into this equation, and that will give me only the letter a. I can solve for a, and then after I solve for a, I can plug it back in and get my time, my final time. Okay, so 176 equals 1/2 a times negative 88 over a all squared plus 88 times negative 88 over a. Wish I had a little more room here. 176 equals, let's see, 88 squared is 7,744, but then I got to multiply that by a half. That's 3872 over a, because I'd have an a squared on bottom and an a on top. And then that's going to be minus 7744 over a. Combine those. What's 3872 minus 7744? Minus 3872. So we have 176 equals minus 3872 over a. Cross multiply, 176a is negative 3872. So a is negative 3872 divided by 176. Negative 22 units feet per second squared. So the brakes are applying a deceleration force of negative 22 feet per second squared. And I can now take that number, plug it in there. My T final is negative 88 over negative 22. Which is 4. So it took that car 4 seconds to skid to a stop. Questions on that? All right, so the next time you're driving down the road, I want you to think about that, especially if you're driving down the road and doing something you shouldn't be doing, like texting. And you're texting and you look up. And you're going 60 miles an hour, how long is it going to take you to stop? Depends on your vehicle, but according to this vehicle here, it's going to take you about 4 seconds, and you're going to slide 176 feet. If there's somebody in front of you, 176 feet is a pretty long way. So keep that in mind when you're driving. Pay attention. Makes a huge difference.